Let's get started. Hello and welcome everybody. My name is Yiğit and I work in Android UI Toolkit team. And for the last 2 years, I spent a lot of time on RecyclerView. And today we will talk about Pro RecyclerView. But what does that mean? I was trying to define this. What does it mean to be pro on something? I think for something like RecyclerView, there's two things. First, you need to understand how we come here. Why do we have RecyclerView? Because we actually also had ListView. How did this happen? And the second thing is, you should know how to best use it. You should be very familiar with the best practices. You should be familiar with the common mistakes. So today's talk will be in two parts. First, we will talk about how we came here, and then we will talk about a lot of different use cases. So part one, how did we come here? So we had ListView, and ListView was designed 10 years ago, maybe even more for lists like this, where things are very consistent. You have an icon, you have some text, and this keeps repeating. And sometimes it's not that consistent, it might be expanding, or some usual elements are visible or gets hidden. And the problem ListView solves is that you have a lot of data, you have a long list of something, and you don't have that much memory, so you only want to show a small portion of this. And the way ListView fixes this problem is, it just fakes it. It only shows the user the views that they can see. Luckily, the screen is not too big. And you only create views for these. And then the whole idea is about faking. And as the user needs to move the screen, you create new elements. And while creating new elements, you actually reuse the existing views. This makes it efficient for a mobile phone. And the user just doesn't understand what's going on. It's good. And you lazily lay out more views as necessary. But what happened to ListView over the 10 years is a lot of things change on the operating system. There was a lot of one-off features. We want to have dividers, we want to have selectability, all these, we want to have a transcript mode. All these things get added into the same class. And ListView had a lot of undefined behavior because most of the time these things first happen in applications. And we tried to move these things into the framework. So you had to rely on behavior of ListView while implementing these features. And then this undefined behavior actually became an undefined API. So even though we don't promise anything in the documentation about the behavior of ListView, people relied on this behavior. So we couldn't change it anymore. And there was another problem with ListView is that after ListView has been created, there is a lot of improvements in the framework as well. There's things like Focus View, where the framework handles this very well, but ListView had its own idea of selection. And then you will see in the ListView code base where it tries to synchronize these two things. The Focus View hopefully should be the selected view, but if they're not the same, we try to pick the right one. It's just a lot of undefined behavior. Or another good example is the click listener. ListView had this item click listener, but actually, the view also has a click listener. What's the difference between adding an item click listener versus adding a click listener on your items? Another thing is items can focus. ListView has this method. The view has focusable property. If they can focus, I will set it. Otherwise, I will not set it. You don't need this kind of methods. And there's, of course, the story of animations. And when ListView was designed, animations didn't even exist. And then the phones get stronger, the UI paradigms change, now you want things to be interactive. So there was a lot of prototypes on top of ListView making this work. Some of them were promising, but a lot of it is regretful. Chet had these dev bites on YouTube. I want you to focus on his face, there's some regret on that face. I'm I'm shooting this video, but I will regret this. And most of the time you're we don't know what will happen. For now, this works. Good luck to you. And the other problem with ListView, or actually the ABS ListView, is that it's really designed for a very specific use case. So as people started asking for different layouts, I want a grid view, or it's I want it to be horizontal or staggered, all these things become really, really hard to implement on top of ListView or ABS ListView because it has some assumptions on how things work. You couldn't even make it horizontal. Even that was hard. So, when you have a problem that you cannot solve, what you do is you restart your computer. So you say, what happens if we reboot ListView? what would we do differently so that we don't end up in the same place? The first idea was we elevate the best practices. So there's things like, for example, viewholder. It became so common that every ListView implementation has a viewholder. You know what? Why don't we just make it a first-class citizen of the API? And then the second thing we wanted to do was decouple things. Like if you try to change anything on ListView, I'm still trying to fix bugs on ListView. It's so painful. Because like there's a lot of things going on. It has a lot of responsibilities, and I cannot change anything. Even though it looks wrong in one case, it might be working fine in the other case that I don't know. So we said these like decouple these things. Like for example, Recycle is a good example. You can provide your own view pool to RecyclerView to recycle views. Or we decoupled the view creation process from binding the view process. So if you remember the ListView adapter API, there was just a getView method, and we will pass you the previous view. You had to like add a tag for the view holder. Like we got rid of all of it. You know, there's an API to create a view, and there's another API to bind a view, and these two things are different things. And we also tried to do less. You know, we tried to get rid of all of the spatial focus handling inside the ListView. Instead, we just like let the framework do what it does. And there's only some edge cases a layout manager has to handle. For example, you are at the end of a layout, sorry, at the end of a like bottom of a list view or a linear layout, and you want to go down. Now we actually know there are more views, so we lay out more views. But these are only edge cases. The rest of the focus traversal on the framework just works fine, and it works consistently. And the last thing we added was a smart adapter. It's like, if you have an adapter, you only tell us like something has changed, it's very hard to produce good output from that. So we introduced these adapters where you can tell us what has changed so that we can do like better animations, better performance. It's just like everything is just better. So from this, very briefly, this is what RecyclerView looks like. We have a layout manager, an item animator, and an adapter. These are our main components. And the layout manager is responsible to position the views. So if there's a new requirement, a new UI paradigm comes 2 years from today, it will be just a layout manager. We have the item animator that handles the animations, because animations are also first class in RecyclerView. And we have the adapter that takes care of the views. And RecyclerView is only in the center orchestrating these things. And as we improve RecyclerView, we are not adding new APIs to the RecyclerView. We always implement components. Like we have the item touch helper. If you want to implement drag and drop or swipe, use item touch helper, which uses other public APIs. They're low-level APIs in RecyclerView, but they're well-defined. Item touch helper uses these APIs to implement it. And everything else we add will be like this way. We are working on adding a snap helper for snapping. And that's like completely different component, doesn't do anything inside the RecyclerView. So this is the first part. I just wanted to briefly go through it. The main talk is the second part, where I want to go through a lot of different examples. Now, this is a little bit experimental. I'm afraid it may get a little bit boring. Hopefully, you can stay with me. We'll look at a lot of different use cases, what happens, why it happens, and what you should do. And this is what makes you a pro, actually. So the main thing is view.requestLayout. This has nothing to do with RecyclerView. This is a part of the Android view system. And you know the view tree looks something like this on Android as you lay out. And when you make some changes on a view, the view says, you know what? I'm requesting a layout because something has changed. It bubbles up to the parent until the root. Root says, fine. Next layout frame, I will call you back. So any view that requests a layout, they just wait. Next frame happens, and then the root view group says to all of its children, measure yourself. Okay, this is your time to get your new layouts. Everybody recursively measures them. Now, if a view didn't request a layout, actually all of its measurement is cached, so it's a very cheap operation, but unless the specs change. So we measure all the views, and then the layout comes, we just reposition the views. Now the view hierarchy is again in a stable state. So what's the implication on RecyclerView? It's a very common on-bind view holder call where you have an image view in your item view where like you bind the URL into that and you have an image loader doing this work. And there's also a placeholder. And let's look at the sample application. So I just like bound all the views. They all have all of the images have their placeholders because the image comes asynchronously. So you finally, your image loader downloads it from the web, turns it into a bitmap, and calls image view, set image bitmap, and sets it. So when this happens, the image view says, oops, my data has been invalidated. Let me request a layout. So it goes to image view's parent, which is your item view in this case. It says, oh, one of my children has been invalidated. Let me request a layout. And then finally comes to the recycler view. Oh, one of my children has been invalidated. Let me request a layout. And it will eventually come back to the recycler view to reposition all the views, which is expensive. It's an expensive operation. So you remember we have this thing set has fixed size in recycler view. This is what we use it here. If recycler view has a fixed size, it knows that recycler view itself will not resize due to its children, so it doesn't call request layout at all. It just handles the change itself instead of invalidating like whatever the parent is, the coordinator layout or whatever. But it's only a limited optimization, still an expensive thing to relay out a recycler view. The good news is that image view since 2011, I look at the Git logs, we have changed how it works where when you update the drawable, it actually checks, like, do I need to resize for this drawable change? If it doesn't need to resize, it doesn't call request layout. It only calls invalidate. Then invalidate says, I need to redraw. My position, everything else is all right. I just need to redraw. It's a very cheap operation. But if you look at the text view, text is like, I have no idea what changed. Let me request a layout. Even if you have set the same text, the exact same string on a text view, call it twice, you will receive a request layout. Just because the internal representation of text view is a lot more complex than the string you set. There's all these like auto-linking and going on, and text view doesn't take care of this. Simply request a layout. This is something you should pay attention and try to avoid, because most of the time, even if you have a text view there, you probably know the size of it. It's like it's a single line, whatever. So how do I know this? It's very simple. You go to Android Studio, put a debug point inside the request layout method in RecyclerView, and if anything is calling that method, now you have the stack trace, you know what to blame, and you can work around the issue. Now, resizing items is like escalation of this problem. Now, in the previous one, you made an unnecessary request layout call, a bunch of unnecessary operation, but the layout looks fine. Sometimes you're not that lucky. So let's look at this staggered grid layout. We have the same image loading code, but what happens if one of these bitmaps is not in memory? So until that image is loading, you want some sort of placeholder, right? Like the layout looks stable. But what actually happens is this. This is what staggered layout manager puts. And I want you to pay attention on the, like the clock. The clock is on the right now. It's actually in the final layout is on the left. But because of the missing information, staggered layout manager, it puts it on the right. Because that first item says, like, I have an image view with a height of 0. Staggered grid is like, fine, I will just measure it this much, and the other view gets positioned according to that. This is bad. You want to avoid this. And the way to avoid this one is, well, write your custom image view. It's very simple. This is a very specific solution for this case, but we have this aspect ratio image view, which can size itself based on a known aspect ratio. So then we override the onMeasure method, we get the width provided by the parent, calculate the height based on that, and set the measured dimensions. When we get the actual image, it will fit in this location, we know that, so image view will not request a layout, plus we gave the correct information back to the layout manager to work around any problems. There was actually a very nice talk yesterday about measure and layout. You should go watch it if you didn't attend. Now, of course, there is a problem because you don't, how do you get the aspect ratio? And if you are given an API like this, your host, like, you cannot work around that problem. That's why I always try to convince people you should work with your, if you are working with an API implemented in your company, you should convince those people to provide you metadata when they pass you data. So this API would be a lot better if they send you the width and height so that you can calculate the aspect ratio. You don't need to fetch the actual image before laying it out properly. And this is not only a problem in staggered grid, like it's even a problem in a linear layout because your views will start jumping as you load the actual images. You should avoid that. And once you go into this mentality, like they can even send you the palette of the image. So the placeholder you put there is actually similar to the actual image. You can do a nice transition between them. You can also hit this problem if you're using data binding, because in data binding, when you update the data in the binding class, it actually waits until the next frame so that all of the changes are bundled until the next frame. But RecyclerView doesn't like this. When RecyclerView calls onBind, it wants you to return the final view so we can measure and position it. All you have to do is call this method, execute every pending binding, so it synchronizes all of the changes you made back to the view. So speaking of data updates, let's say we have an example application like this where we display the list of news, and you refresh the data, you get the new list of news from the server, and you update it. And the update code looks something like this: set the news on my adapter and call notify dataset change. Once you do this, it will look like this. It will instantly go to the new view. The views have been updated, but it's not the best user experience, right? The layout just jump into the new one. It's actually, if you look at detail, there's something even worse happening there. So when the RecyclerView is handling that dataset change, you don't tell us anything about what has changed, and RecyclerView goes, okay, I had this previous item at position 0, hopefully it is still at position 0, so let me rebind it to position 0. So it goes, binds that item to new position 0, and does the same thing item 1, and then 2, 3. As you can see, like we had, for example, the first news, Sharks to Finals, we had that thing ready, we bound it to this other news, and then we had the Shake the Phone news, then we bound it to Shark the Finals. This is like a super inefficient operation. And then all these like text view, you have invalidated everything. And then you needed a new view to add the previous one that you actually already had, but you misused. You create a new view holder for this. Now, of course, there's a very easy solution for this. You make your adapter has stable IDs. And probably if you have an application like this where news have IDs, you just implement this API, set my adapter has stable IDs, and once you do that, RecyclerView will nicely animate the view. Now, this looks good to the user, but there's still something inefficient here because we had to rebind all these views. Although they're like completely valid, we had to rebind that item back to itself. Now, thanks to the stable ID, we knew what position to rebind, but we still had to do it. When we do that, of course, everything just invalidated themselves, and they had to be remeasured and relayed out. This is because the notify dataset change with stable IDs only gives us enough information to reuse the correct view holder, and that's it. So to work around this issue, we provide sorted lists, which is a simple collection implementation that keeps the elements sorted, and it has the built-in logic to send notify events back to RecyclerView, or is actually a common API that works well with RecyclerView API. So when you want to use a sorted list, all you do is you implement this adapter callback. And there are 3 methods you have to override. One of them is compare, which simply tells which item I put first, and the next one. And the other one says, are these items the same item? This is like the stable ID API. You simply compare the IDs of 2 items. And the third one is, are the items the same? So by using this API sorted list can just say, you know what, this news looks the same, I will just not tell anything about it. So that RecyclerView can just reuse the same view holder without calling any other method. And when you reuse the view holder as is, it's very cheap because all of the cache just works. And when you use sorted lists, all you do is when you fetch the list of news, you add them to your sorted list, and that's it. It takes care of notifying the adapter as the data changes. Now, let's say we wanted to sort our news by the number of votes. To do that is very simple, right? You had one compare method. We will change that to instead compare by the number of votes. So now all of the items will be sorted by the number of votes. But let's look at the internals of how sorted list works. So when we had let's say we had this list of news, and we get the updated list of news, and in there we have this 2rx or not 2rx news with the new vote count 9. When you try to insert this into the sorted list, it simply does a binary search. So it goes to the middle item, is this above or below, above, goes up, above, below, below, whether it finds the right position and inserts it there. Now the item has been inserted in the right position, but we have a problem. We have just duplicated the item because sorted list had no idea that this item is already in the list. So how do you work around this? Sorted list provides a method called updateItemAdd when you need to reorder items. We have to do a little bit more work because sorted list only has this sorted list of items. It doesn't have any additional data. So we'll keep it ourselves. We'll have a map that maps the item ID back to the item because item ID is stable. Like you need something stable that you can rely on. And we'll have our own insert method where we put this item into this map, and the map class actually returns the existing item back to you. So we know if the item already existed in the list, if the item didn't exist in the list, it's simple, we add it. But if the item was already in the list, we call this other method, find the index of it, and then tell sorted list to update that item. Now it will recalculate the position of the item and also dispatch the necessary notifications back to the adapter. Now this works very well, but it's case like if you also have deletions, you need to do a lot of bookkeeping. It's not very straightforward. And we have something better coming up for this. So in the next version of RecyclerView, we will have this new class called diffutil, which is very simply you have two lists and it calculates the difference for you. Magic. So let's look at the API very briefly. You call diffutil, it has this calculate diff method, and you pass a callback, very similar to sorted list. It will return you a result. You just update the list in your adapter, just like set to the live list, and you call this result.dispatch updates to method to dispatch all of the updates to the RecyclerView. And now you get all of the benefit without almost doing anything. So if you look at the callback class, there's 4 methods you have to implement. The first 2 are simply get the size of the old list and get the size of the new list. Now it actually doesn't require you to have lists. You can have anything that provides random access because this callback just works with positions. So you implement the very similar method which says, are these items the same? It checks by ID. And you have this other one, are the contents the same? It tells us whether has there been any changes on this item? And from this, it's going to dispatch all of the move, update, removal, all of the events for you to the adapter. There's also an optional API in this callback where you can say, you know what, I can actually tell you what has changed in this item. So if you had the votes has been updated, you can say, you know what, I will check the vote numbers of these 2 items. And diffutil will only call this method if you told us like these are the same item, but it has been changed. We ask you, okay, give me the change. And you can say this votes is just any random object that you can have in your code base. The nice thing about this API is we will pass it back to the onBind method in your adapter if and only if we reuse the same view holder. Now in the onBind method, the nice thing is you are given a view holder that's already representing that position. Like you know everything is bound to there. And the payload includes a list of things that has changed. So you can only update those things. This will be super efficient. You will do less work, and you can actually nicely animate based on these payloads. So the payloads will be empty if the view holder is not reused for the same item. In that case, you just run your regular bind logic. Otherwise, you look at, okay, if the payload contains the votes, let me change the vote count and only change the vote count because I know the other things didn't change. So diffutil will be available in 24.2, hopefully somewhere in August. We don't know the exact dates now. So another common question in RecyclerView is that how do I do resource management because I have these expensive view holders here and there. So to understand this, you should know the life cycle of a view holder. This is a very simplified version, but a view holder is created via onCreate, and soon after we will actually call it to bind it to a position. Once it's bound to a position, you can expect it to be attached very soon to the view. Once you receive this callback, you know that viewHolder is on the screen, probably visible to the user. And after maybe the user is scrolling or something else happens, the item might be detached. Like you're scrolling, it went out of bounds, layout manager decided to remove that item, and we will call onViewDetach from window. At this point, you know it's still not attached, but the important thing is we may reattach it without calling any other method, because we know this item still represents, this view still represents the same item. We could just reuse it, even though it has been removed and re-added. So if you have, let's say you have video playing feed items, you could stop the video when the view is detached and restart it when it is attached. It's a nice way to understand like this item is becoming visible and invisible. Now, we may recycle a viewHolder. Once we recycle a viewHolder, that means we will always call onBind. It may or may not be the same item. Probably it will be a different item, but we will always call onBind. So when our recycle is called, it's actually a good time to release the expensive resources. You know, if you had a bitmap, let's release the reference to the bitmap so it can be reused. Because when onBind will call, you can just reallocate all these things. So in the onBind method, in this case, you will acquire the expensive video resources because you have released them. So RecyclerView is asynchronous. What does this mean? This doesn't mean it is multi-threaded. It only means that it handles stuff asynchronously. So if we look at an example, when a frame happens, RecyclerView makes all pending changes into the views, updates itself. After all these changes have been updated and the frame has finished, anything else you call afterwards, you can call scrollToPosition, change the adapter, dataset change, whatever, everything is deferred until the next frame. And when the next frame comes, RecyclerView applies these changes. This has some implications. For example, if you call RecyclerView scrollToPosition 15, and then you call layout manager, get me the first visible item, is this going to be 15? Actually, no, because we didn't do that yet. You just told us, okay, I will scroll, fine, but we didn't do it yet. So if you expect it to happen instantly, it won't. There are multiple reasons for this. One of this is very inefficient. The second part is you want these things to happen together so they look synchronous. So if you are initializing your RecyclerView in your activity, in your onCreate method, you could say scrollToPosition, selected position, and here is your adapter. So is this going to work? The answer is yes, because both setting the adapter and scrolling to position will be handled the next frame, so it will work just fine. Otherwise, if we're trying to handle this synchronously when you call scrollToPosition, or you know what, I don't have an adapter, sorry, continue. We don't want that to happen. And this has other side effects which are really good. For example, the other use case, when you create an adapter, you actually usually don't have, when you create an activity, you usually don't have the list. Like, list comes from the database, comes from the network, is asynchronous. So you cannot set it up like that. But you know the selected position because you open the activity with some reason, or it comes from saved state. So you can call save instantly, and then you load items. Assume this is an asynchronous call. When the items are loaded, you set the adapter. Now, is this going to work? Because the next frame happened, we still don't have the adapter. Good news is that it will work, and the reason it works is slightly different. When you have a RecyclerView, and if you didn't set an adapter and a layout manager, it just skips all of the layout calls. This is very useful because, again, in the same example, things like saved instance state, we get some information like latest scroll position, whatever, instantly, but the data comes asynchronously. So as long as you don't initialize it, which means you don't set an adapter or layout manager, everything else will work just fine. As soon as you set the adapter, we will reuse that pending scroll position or all of the pending information we had about the RecyclerView. Okay, another thing is, so earlier in the talk I mentioned we wanted to elevate best practices, and this is one of the things, the view holder. Now we force everybody to have a view holder. But of course, when we do this by force, and so I call this a set view holder because it has all the views. It did run find view by ID once, which was the original idea behind the view holder. And then you have your onBind method, which gets the item, gets the view holder, sets all the fields. And I call this a set view holder because it's really disconnected. Instead of doing this, I suggest, this is just the best practice, you don't have to do it, but write your view holders like this. So you define the views again and create a bind method. Like, I know this view holder can represent an item, and it also needs the image loader to work. So you create this bind view method, set these things, and in your onBind method, in your adapter, you simply give the item to it and everything else it needs. Now this is much more well abstracted. You can use this view holder in other places in your application. It's like a presenter, and it just works very well within itself. Another nice little thing with view holders and view types is that, let's look at this example. So in this view, you could have view types, but you had to say, you know what, I have 5 view types. In RecyclerView, this is different. You can have any number of view types. So if you had this get item view type method, we check is the user's premium. If it's premium, return the premium type. Otherwise, return the regular user type. And in our onCreateViewHolder method, we will implement something like this. We will check the view type. If this premium, inflate this one. Otherwise, inflate this other layout, create the view holder, and return. Now, this is OK, but it's not great because now you have 2 different code pieces. They're actually supposed to work synchronous. And you may break this. You have to test this very well. We could do a nice little trick that works around this issue. You know what? Instead of returning type, just return the layout. We know these layout numbers, they're integers, they're auto-generated, they are guaranteed to be unique. So you know what? Just return the layout. Once you do this, if we go back to our onCreateViewHolder method, we can get rid of all of this logic. Just do this. Whatever the view type that was passed is actually, we know is this the our layout ID. We use it to inflate and then return. Now, of course, you cannot always do this, but when you could do that, this is actually a very nice, clean way of doing things. OK, click listeners, another sensitive topic in ListView to RecyclerView transition. So when we release RecyclerView, someone asked this question on Stack Overflow. Why does RecyclerView doesn't have an item click listener? How come? And it has almost 500 upvotes. So it seems like it's a pain. Like when I saw this, and it was my early days in the team, I said, OK, I think we should implement this as soon as possible. And then Adam Powell was like, no, we don't do that. It's like, why? Because I didn't know. Are we really bad people? We want them to suffer? No. There's actually a reason behind it. And so there was a reason behind it. The nice thing about the community is that someone else replied. And the reply has almost 800 upvotes. So I took this as a compliment. You know what we did is actually the right thing. The problem was, all this, like the previous thing I mentioned, the duplicate functionality issue. If you add an item click listener on a list view, then you were unable to click anything else inside those items. And like, it's very hidden. How would anybody think about this? And now you'll get all these Stack Overflow posts about, hey, click listeners doesn't work in my list view. Why? This is why. You know, we did something wrong, and then we got rid of this. So how do you do a click listener? What's the nice way of doing a click listener in RecyclerView? There's actually one major change. So it's an adapter. I want you to look at this class name. It's not called view click listener, it's item click listener. Because if you have a list of something, and something is clicked by the user, you don't care about the view, you care about the actual item. So create this class, something says, it can be a callback class in your adapter that handles multiple action callbacks, or it can be, in this case, it's as simple as item click listener. So in your onCreateViewHolder, this is the other important thing. When you create the view holder, attach your click listener. When the click happens, you call viewHolder.getAdapterPosition. So viewHolder has this method that returns you the adapter position of that view holder. This is very important because as the items might be moving in the adapter, we will not rebind that view, but you always have this getAdapterPosition. So by the time you bound it, it could be at index 5, but by the time user clicked it, it can be at index 10, and this getAdapterPosition returns you the correct index. Now you have to check this position against noPosition variable, which is -1, because you may just deleted all the items from the adapter, but before RecyclerView could refresh the view, remember it's asynchronous, before we could refresh it, user might have clicked on the item. So you checked it against noPosition. If it is not noPosition, now you call your item click listener with the item itself. This is a much nicer, well-defined API. Because you are interested in clicked on the item, you pass it back to the callback. And finish. Now another question we get a lot, and someone pro in RecyclerView should know, is what's the difference between an adapter position and a layout position. If there was something like a RecyclerView interview, I would ask this question. So this is a layout, like list of items. The AP stands for adapter position, LP stands for layout position. And they're actually the same. Most of the time this is the case. But in your adapter, if you say, you know what, I have moved position 2 to position 5, then these adapter positions and layout positions go out of sync. Because we know adapter context has been changed, but we have not yet recalculated the layout. During this time, layout positions don't match the adapter positions until the view system says, okay, you know what, you should layout yourself now. When we receive the callback, we reposition the views, and now they are synchronous again. So if you say, okay, when do I use which one? It's kind of confusing. It's actually not that confusing. If you need to access the adapter, like the previous example of clicking an item, you want to access the item, so you want to access your adapter, use the adapter position. But if you want to find like what is the view before this one while user clicked on this thing, then you want to use the layout positions. And internally, layout managers only know about layout positions. They don't know about adapter positions. And the rest of the code base uses the adapter positions. Okay, this is the last section. This is my complaints. There's things, so when I was preparing this talk, I went through the public bugnizer, the internal bugnizer, Stack Overflow, like my emails. I tried to find all these edge cases that I mentioned earlier. It's like, how do you do these things in RecyclerView? What are the things people got wrong and we could do better? But these ones that I will mention, they keep coming up. I don't understand why. Like I mentioned them in many other talks. They just keep coming up. So I want to mention them one more time. First one, this is super sad. People create this thing called my super solid RecyclerView, whatever that is. They extend RecyclerView. They extend the onLayout method, and they just write this code. Like, try calling the super. If it fails, just eat the exception and continue. You cannot do this. Like, if we could do this inside RecyclerView, we wouldn't throw the exception. If we are throwing an exception, that means there's a problem. And like, from my experience, this is probably in your application. You are doing something wrong. So instead of doing this, go fix your application. And if you think the RecyclerView is doing something wrong, go report the bug. What people are doing is they put this code, 2 months later, they start hitting another issue. They report that bug. I'm looking at the bug report like, this doesn't make sense. How come RecyclerView ended up in this state? It happens because they just ate a previous exception. So RecyclerView just became unstable because we don't clear things. Like even the reference counted stuff inside RecyclerView, we don't put them inside try finally blocks because if we hit an exception on main thread, we should die. Like, that's not recoverable. So try to fix these things or provide a bug report. It's the other part. The old habits, they die hard. Okay, how many people realize the problem in this code? Something is wrong in this code. 1, that's it, okay. All right, how about this one? What's wrong in this code? It's another clue. Come on, just mentioned it. Okay, I did this. Set on click listener, when something is clicked, change the item and notify item change. You cannot do this. The position we have provided is not final. It used to be final in ListView days. That's gone. It's not final. That's why we provide you this getAdapterPosition method. You cannot do that. And then plus, also don't do this. Like, don't keep recreating an object every time we call onBind. This is why I suggest people to create their listeners in onCreate. Sometimes not very appropriate, but in onCreate, you just don't have a position, so you cannot make that mistake. Even though I have seen someone, they sent me a code in onCreate, the integer variable, instead of viewType, they named it position. They thought that was the position. Sometimes happens. But whatever, like this is, I know it's how it used to work in ListView, just forget about it. Another example I see is very common. I just saw this like 2 weeks ago. In onCreateViewHolder method, if you have headers, it's a very common implementation. If the type is a header type, check the header viewHolder is null. If it is null, create it, and then return the header viewHolder. You cannot do this. Look at the method is called create. Look at the description. It says bring something into existence. Did you bring anything into existence when you return me the same viewHolder? The problem is that RecyclerView would not call onCreate method if we did not need a new viewHolder. You are fighting against the RecyclerView, you are defeating the purpose of the well-defined API. Of course, you are probably wondering, well, I created this viewHolder before, why did it get lost? There's a method called onFailed_recycle. RecyclerView probably failed to recycle the viewHolder, or it just wanted two of them to run some animations. You should look at the RecyclerView API, implement this onFailed_recycle method, and then do the right thing, see why it is failing, and there's a nice way to recover these views. But just don't fight with the API. And the last thing, again, I see these people trying to fool the RecyclerView. So they first write this code, I have an async test, I fetch new items, I set the data on the adapter, and I call notify data set change. Then we say, no, you cannot call notify data set change on a background thread. You have to call it on the main thread. They're like, cool, sure. I will do the same. I'll just move it to post execute. I will change my data on the background thread and notify on the main thread. It's like, we are not bad people. If it was only about moving the call to the main thread, we would do that for you. There's a reason for this, because as you change adapter data, RecyclerView might be in the middle of laying out these items. So, for example, RecyclerView just told the layout manager, okay, you have 100 items to lay out, then you deleted 50 of them. While the layout manager is laying out items, it asks for the item at position 60. We are like, ooh, out of bounds exception because we don't have that many items anymore. There's a reason for this. You cannot do that. Don't try to do that. Calculate your data on a background thread. You should do that. But update the adapter on the main thread. You can actually even do this with diffutil. One of the reasons the new diffutil class returns a result is that you could run it on a background thread. If you have thousands of items in your list, it may take a while to calculate the diff. So you should run it on a background thread. And then you can pass the result back to the main thread and change your adapter data at the same time do you dispatch the updates. Just the important part is, while you are calculating it, you should not be modifying the data, otherwise the diff result will be invalid. And with this, I conclude my talk. Thank you. I think I have time for questions, but before we do this, since you went through this, here's a little certificate of achievement. Congratulations. It's for you. Okay, I think I have some time for questions. So the question is, if I'm writing a new app that ListView works for, should I use RecyclerView? No. If ListView is working for you, if you don't need anything from RecyclerView, you can use ListView. We didn't deprecate it, it's still there. So the question is, if you have views which are clever enough not to request layouts or invalidate themselves, it's still worth calculating the diffs instead of using notify data set change with stable IDs. There's still there's still little difference. Well, we won't be calling on bind. And there's this thing called predictive animations, where when we know what actually has changed in the adapter, we can run better animations. In this example, it wasn't visible, but we could as well be, as we add more items, and the other items are going out of bounds. If you do notify data set change, if there's 5 items going out of bounds, some of these would fade out instead of moving down because we didn't know where did they go. So it's still better to calculate, and I think with diffutil, it's you just don't need to do anything. It's very simple. So the question is, if you have a list of items, but you want to have an empty view while you are loading the list, would you extend the RecyclerView to have this functionality? I don't know. I would probably not. Like things like an empty view, you can simply like have a parent on RecyclerView, like position whatever the progress bar to the parent of RecyclerView and hide the RecyclerView. Because RecyclerView right now doesn't really handle children that are not items. We have plans to support this, but we don't have it yet. So whatever you do will be like a little bit hacky. So I think it's better to keep it outside the RecyclerView. Yes and no, we said no. But we have this divider item decoration that was in the demo applications, and we are moving it to the source. So you will have divider item decoration, you attach it to the RecyclerView. So it's like the mentality change in RecyclerView. Instead of saying set dividers, you create that thing and attach to RecyclerView. So the question is there any plans to add new features like sticker headers? I think they're from the Super Slim library. The funny story about sticker headers is we had it, we removed it. Like I implemented and removed it. We want to implement something called extension views, where you can put additional views into RecyclerView that are not actual item representations. It's a good example for sticky headers. I did it and I didn't like the API. It's like it didn't feel well, so we removed it. I think we will revisit that idea. We know this is necessary, especially for things like sticky headers. Today you can do it with item decorations, but they cannot be real views. And hopefully we will implement that API sometime. We don't have them yet. So the question is, with ndViewTool coming up, do you plan to deprecate notify dataset change? It's like, I would be so happy if I could do that. But we cannot do that. There's still cases like your data might be coming back from a cursor bound to some other process. You may not be caching it on your site. Even though ndViewTool works based on indices, like the whole idea about using a cursor is that you lazily get the items back, but ndViewTool will have to query every single position, so you will be accessing everything, and if you're going to access everything in the cursor, you are better off like moving them to an actual list. So there's still some edge cases where you may want to use notify dataset change, but hopefully like there's this bug report on the public buganalyzer that has almost 200 comments about people sending the wrong notifications and RecyclerView crashing, or sometimes RecyclerView doing something wrong and crashing. Hopefully I will get rid of those. Okay, maybe. Okay, thank you very much.